Mystery object. Sivan, Victoria, and Charles. So we have this mystery object. We found it in our garage. We have no idea what it is. In order to find out what a specific substance is, you have to calculate things that are specific to it. Things that are specific to substances are the density, the specific heat, and the melting point. For our experiment, we decided that we were going to calculate the density and the specific heat, because the melting point we assumed would be much too high for this metal object. The purpose of this experiment was to be able to distinguish substances by their properties, such as density and specific heat. Density. Density is mass over volume, or grams over milliliters. In order to calculate density, first we have to calculate the volume of our object. We fill a graduated cylinder with water and take note of the first water level. Then we drop the object in and take note of the second water level. As you can see, the water rose from here to here. That is the volume of our object. Next, in order to measure mass in grams, we take a mass balance and we weigh the object. To calculate specific heat, first we have to be able to heat something up. So we take some boiling water over a Bunsen burner and put our substance in. We wait several minutes and our substance becomes around 100 degrees. Then we take an insulated cup filled with a specific mass of water that we know the specific starting temperature of. We drop our 100 degrees substance in and wait several minutes. After several minutes, we are able to take the temperature of the water and see how much it has changed. Now, when it comes to calculating specific heat, we have to calculate it in joules over grams times degrees Celsius, as in how many joules of heat does it take to raise 1 gram of our substance 1 degree Celsius. In order to calculate this, we have to use the specific heat of water. Because we know the exact change in temperature of the water and the exact mass of the water and the specific heat, we are able to solve for joules. The number of joules taken into the water is the same number of joules released by our object. Then we can solve for joules. Now we have to divide by the grams of our object, which we can weigh on the mass balance, times the change in temperature. The change in temperature of the object is 100 degrees minus the final temperature of the water, because that's how much heat the substance lost. And using that formula, we are able to calculate the specific heat.
To find the density of the mystery object, we divided mass by volume. Even with varying masses of the mystery object, the volume of water that the object displaced was a consistent 6.5 milliliters. This is the graph of Table 1. As you can see, all 3 trials and the average resulted in the same density of 2.6 grams per milliliter. By plugging in the numbers from each trial in the specific heat equation, we found the value of the specific heat per trial. So we did C equals the energy of the water divided by the product of the substance's mass and the change in temperature of the substance from 100 degrees Celsius. This is the graph of Table 2. Here, there are different values for the specific heat of the mystery object. In Trial 1, we had the result of 0.7 joules per gram degrees Celsius. In Trial 2, we had the result of 0.4 joules per gram degrees Celsius. And in Trial 3, we got 0.1 joules per gram degrees Celsius. The average of these varying values of specific heat capacity was 0.4 joules per gram degrees Celsius. Overall, the average density found was 2.6 grams per milliliter. The average specific heat capacity was 0.4 joules per gram degree Celsius.
According to Reed Advanced Materials, the density of cast hammered aluminum ranges from 2.55 to 2.80 grams per milliliters. However, the density of an iron slag is very similar, 2.6 to 3.0 grams per milliliters. The mystery object's density of 2.6 falls into both categories. Moreover, it was a precise value as all 3 trials yielded that number. The object's average specific heat was determined to be 0.4 joules over grams degrees Celsius. However, this was the average of the values of 0.7, 0.4, and 0.1, a wide range of numbers. Iron-specific heat, according to Tudor Vista, is 0.4494, which falls near 0.4. Because of the imprecise results of the trials, specific heat can match several transition metals such as zinc, titanium, and scandium. This does, however, eliminate aluminum as a possible result because the specific heat is 0.9 joules over gram Celsius. In addition, because of the object's dull gray appearance, substances, including copper and chromium, can be eliminated. Fortunately, this is where the calculation of density comes in handy in deciding what the mystery object was. According to both of our sources, the iron slag's density and specific heat is closest to this lab's calculated values. An iron slag's density is between 2.6 to 3.0 grams per milliliters, while the mystery object's density is 2.6 grams per milliliters. Iron's specific heat is 0.4494, which is near the object's average value of 0.4. Based on this information, it is possible to make a conclusion on the identity of the objects. Density and specific heat are properties unique to every substance. Because these particular properties match up between the object and iron slag, the mystery object is most likely an iron slag. A possible source of error is faulty measurement of the object's mass. The object was placed in a graduated cylinder full of water to measure its volume through water displacement. Although it was dried off before it was weighed, it is possible that water could have clung to it and caused its mass to appear higher. In turn, this would have increased the calculated density, which could mean that it is actually an entirely different substance. Particular substances have very unique properties that allow them to be easily separated and distinguished. Among these are density and specific heat, which were used in this experiment, melting point, boiling point, flash point, or all other specific properties. The purpose of this experiment was to identify an object through the comparison of its properties to that of known substances, so future work may utilize the manipulation of other properties.